Hello, welcome back. Now we want to continue this lecture with, um, first of all, reviewing the books I'm using for this course, and then go on and look at what modeling is, and then introduce what a pseudocode is, and our third lecture will take care of the exercises which I talked about in the first lecture. So let's look at the books. Now I'll begin by looking at some codes. Now this is normally supposed to inspire my students so that as we go on and you start having challenges, please remember how we started. It is not the load that breaks you down, it is the way you carry it. Now you are coming from various backgrounds. Some of you from SHS, some of you from a working environment, others might have written this and they've stayed at home for some time. So they are now coming and joining at certain stage. I'm just saying that your way that you were introduced to learning or studying materials, as you go on, you start have to reinvent the wheels and find out what really works for you. Please, so as we go on, it's the way you have to adjust. So it is not the problem, or it is not the cause, or like some of you very soon will start identifying, may not necessarily be the lecturer. Even if it is a lecturer, there is a way you can readjust and get the best out of the situation. So please take note. The second one, normally, if I'm in a lecture room, I will refer to a clock which is not working. Is there nothing in the world is ever completely wrong? Even a stop clock is right twice a day. If a clock stops at 12 o'clock, then it means that anytime it's 12 midday, it is correct. Anytime it's 12 midnight, that clock is also correct. The point is, you can't write yourself off. A lot of people, I know a lot of people who have phobia in maths. So before you even start teaching them anything, there is the fear factor. I just want to remind you that no matter what your background is, you have enough to help you to be able to take this course and excel. That is the import of this particular quote. Now, these are the books I talked to you about. Those of you who haven't been able to download those which are downloadable, please do. I claim I'm using this first book, Discrete Maths by Rod Haggerty. And I'm saying it's on online. You can download it, you have to buy it. But I recommend just use my resource materials that I'm using and these two other books, Discrete Maths by Kenneth Rosen. This is downloadable, and then Fundamental Approach to Discrete Maths. These are all books, especially the second and third. I have electronic versions. Okay, they are quite huge. So even if you want me to share it, then I have to share it on a shared folder of some sort. Now we want to really address our first topic, which has to do with algorithm. But before we get there, let's understand some basic facts. Now, if you want to understand how something works, we first of all must achieve what we call a model of it. Okay, when you look at huge buildings before they are put up, there is a miniature drawing or a miniature sketch for whoever the planner or whoever the project manager will always have and look at. That will tell him to know what will come first, what will follow. So what we are about to do is to understand how something works. And for example, we want to understand how a computer works. We need to acquire what we call the tools and the techniques. So the tools and the techniques that will help us to understand how a system works is what we are now doing. Now, let me put it another way. If you have a problem, for you to get a solution, there is always, or there is a process that you have to go through. Have an idea, which is abstract, it will be in your head. And if you're able to transform that idea into something that works, then you have what we call a transform model. An example, let's say you are from Tesano and you want to go all the way to Accra Central. Your problem is you want to move from Tesano to Accra Central. That's your problem. The solution is to be in Accra Central. Now, the idea that will be in your head is If you have the energy, I can walk. That's an idea. Or I can drive if I have a car. Or I will take public transport, Uber, Bolt, Trotsky. These are all ideas. Now, when you decide by moving to the roadside and picking any of these particular ideas, then you transform that abstract idea to something that is a model to work in. So you sit in the vehicle, and then that gives you a transform model. I hope this picture or this explanation may play or give you an idea of what we're about to do. So now I'm going to give you a typical problem. I want to start trying to address this topic with a problem. Now there are two of them. One of them is realistic, the other one is not realistic. Please pay attention. The data you're about to see may not necessarily be correct, but the idea behind it is that when you pick that data and you're able to work with it, then you can use any other data from any other source and be able to use it. You will understand what as we go on. Now, those of you who are familiar with Ghana, these are towns in Ghana. We claim that if I pick these cities or these major towns in Ghana, Accra, Flower, Akosombo, Bolga, Cape Coast, and Kumasi, and you want to travel to all these towns, the question you want to ask yourself is, which route should I pick? So that by the end of my journey, if I calculate where I started, the next time I went to, till I visited all the 6 towns, which one will give me what I call the minimal or the total length, the minimum total length. Now, I picked this particular data from the net, so this is realistic. Now, I'll leave this assignment for you after I have manually taken you through the next one. Now, look at the next data. Now, this particular data is not realistic. Now, if you pick, for example, those of you who are familiar with Ghana, Accra, Edina, Koforidua, Cape Coast, Takoradi, and Yendi. Those of you who know Ghana very well, you know that Yendi is in the northern part of Ghana. But from my data that I have here, Accra to Edina, I have estimated a distance of 120. Accra to Koforidua, 147. Accra to Cape Coast, I've written 142. Accra to Takoradi, 107. Accra to Yendi, I've written 81. And I'm saying those of you who are familiar with Ghana, you know that Yendi is the furthest away from Accra. And yet that is the smallest value. And I'm saying I intentionally did this so that we won't end up using our pre-knowledge of the place. The issue is that if I change these towns to towns, for example, in Nigeria, Lagos, Abeokuta, Kaduna, what do you call it? Benin City. If I change these cities to cities that I'm not familiar with, all I will know is the distance. So if I don't know the towns, can I still go through this particular problem? Okay. Now, so the question we want to ask ourselves, where do I start this journey? We want to travel through all these cities and make sure we go through all these 6 towns. At the end, we want to find out what is the shortest distance or the shortest approach to this. Okay, how do we go about this? I'm going to share an Excel page that will help me to explain this better, and then we'll come back to the slide. Okay. So I have here the question which I have just framed in the PowerPoint, and I will want all of us to go through this. I'm going to just do just one example, 1 or 2 examples, and I'll try my best to go over it so that we can all understand. Now, look at the problem carefully. I have a data on my right that is giving me the distance between these towns. Now, what do I want to do? I want to find out where do I travel from and where do I go to, so that by the end of my journey, I should have the shortest distance. That is a problem, what we call the minimal distance joining all these 6 towns. Now, on my left, I'm using Excel. I am assuming if I pick this journey from Accra, let's say that this problem, I want to start from Accra, okay? So I have here Accra. Now, if you come to my table on the right, you look at Accra horizontal row, and you see that Accra to Accra is 0. Accra to Edina is 120, Accra to Koforidua 147, and so on and so forth. Now, what should inform my decision? Now, I did this earlier, but I will show you how this is done. What should inform my decision? Because I want to solve this problem so that by the end of my problem, I have what I call the minimum distance, total distance. The criteria to solve this problem is to look at the smallest value or the smallest distance away from Accra. Now, if you look at, again, I've done this, I'm taking them off so that I redo them. If you look at Accra, the smallest distance away from Accra is Yendi, 81. So from Accra, the next town I'll go to, I know you've seen it already, but I'm going to redo it. I'll go to Yendi. Now, what's the distance away from Accra to Yendi? Is 81. So down here, I'm going to place 81 here. So why didn't I choose Edina? Edina is 120. It is far bigger than 81. 147 is also bigger than 81. 142 is bigger than 81. So the smallest value is 81. So from Accra, the place our journey to is Yendi, which is 81 kilometers away. Now then I come to the table again. I'm no more in Accra, I'm now in Yendi. So I'll come and look at the Yendi horizontal row. Yendi is the last row here. And then I'm going to look at the shortest distance away from Yendi to the next town. Now, Yendi is made up of 81, 45, 105, 61, 112. Make sure you don't go to the town you have been to already. So if you look at the values here, the smallest distance is 45, and the town there is Edina. So it means that from Yendi, I have no option than go to Edina. Okay, and the distance away is 45. Okay. Now, then I come here. I'm now in Edina. Edina is the second row. Again, I look at the rows of values. Edina is made up of 120, 132, 42, 157, 45. The smallest distance away from Edina is Cape Coast, and which is 42. So the next town I'll go to is Cape Coast. Just write in just Cape. And the distance away is 42. Okay? Now, then I come here. I'm in Cape Coast. Cape Coast is this row. I'm looking at the values. The values here, the smallest value is 42, which is Edina. I've already been to Edina, so I'm going to skip this. The next smallest value is 61, which is Yendi. I've been to Yendi too, so I'm going to skip 61. The next smallest value is 108, which is Koforidua. So the next time I'll go to is Koforidua. I'm going to write a short form of it. And the value there is 108. Okay? Now remember, I started from Accra. I went to Yendi, 81 kilometers, Edina 45, Cape Coast 42, Koforidua. Now I'll have to go to 6 towns. I left Accra. Now I've done 1, 2, 3, 1, 2, 3, 4, 5. So what's the last town I need to go to? Now I'm in Koforidua. The smallest value from Koforidua is 66, which is Takrady, and I've not been to Takrady. So the last town is going to be Takrady. So I'm going to put the value here, which is 66. Now, when you check, the total kilometers that I have traveled is 342. Now, I'm going to do one more example, and that will be will make us make an informed decision. Now, I'll leave the rest of the example for you to try, and from then we can take a decision on which road should I pick? Where do I start from? Where do I go to? And what will give me my next value? Now, the first one I started from Accra. So next time I'm going to start from Edina. So again, let's go to Edina. Edina is made up of 120, 132, 42, 157, 45. The smallest value is 42. So the town is Cape Coast. So Edina, I go to Cape Coast, and the value is 42. Okay? Now I'm in Cape Coast. Look at the Cape Coast row. It's made up of 142, 42, and 108, 168, 61. 42 is Edina. I've been there. That's where I started from. The next smallest value is 61, which is Yendi. So from Cape Coast, I go to Yendi. And the value is 61. Okay. Now, I'm in Yendi now. I look at the values here. The smallest value in Yendi is 45. And the value and the town is Edina. Remember, that's where I started from. So I cannot go to Edina. Okay. The next smallest value is 61. And 61 is Cape Coast. I've also been to Cape Coast. So the next smallest value is going to be what? 81. And 81 is what? Accra. So I'm going to place Accra here. And the value here is 81. Okay, now I'm in Accra. Accra, the smallest value is 81, which is Yendi. I've been there. The next smallest value is 107, which is Takrady. So from Accra, I go to Takrady, and which is 107. Now, the last town from Takrady, look at the row for Takrady. The smallest value with Takrady is 66, which is Koforidua. So the last town I need to visit will be Kedia, which is what? 66. Now, if you check, the first one gave us a kilometers of 342. The second one gave us a kilometer of 357. And I bet you, as you go on, you realize that the values will be changing. Now, so what problem are we trying to solve? We don't know which town to start from and continue to the next town. So we've done all this. Now, these are only 6 towns. So if you want to manually go through this, that is like giving you a laborious work. So we need to use something, well, in computers, and we call it a program. But before we get there and start looking at what codes to use and what all that, I'm teaching mathematics. I'm going to show you a technique in math called graph theory. So I'm going to go back to my slide, explain what graph theory is, and come back here and come in and show you how this is done. Okay, so back to our slide. Now, so our proposed solution to this, remember when we did, we tried to find out what will work. From Accra, we got a value different. From Edina, we got a value different. So what if this work has to do with over 100 towns or 100 cities or infinite number of towns? We can't do this manual labor. So I'm saying we propose a solution that we call graph. Now, I know this is the first time I'll be talking about graph in this sense. I know you may think graph is X and Y axis only. Please, in discrete maths, when we talk about graph is simply a connection from one point to the other, okay? So anything that we can draw a connection from a beginning and then an end. For example, you take your WhatsApp. If you're in a WhatsApp group, all the people in the WhatsApp group can communicate to everybody at once or to individual members. Now, so that link of the group members is a graph, okay? Now, if you take a family, a nuclear family, father, mother, children, the relationship between the parents and their children is a graph. The father is related to the son, the father is related to the wife, the children are related to their parents. That's the graph. So please, when I mention graph, I'm not referring to simply an X and Y axis. In computational maths, I'm sure you'll learn more about X and Y axis, but here, a graph is simply made up of vertices and edges. Now, if you've done any figure drawing in your preliminary years, you know that a rectangle has made up of 4 corners, a square is made up of 4 corners, a pentagon is made up of 5 corners, a hexagon is made up of 6 corners and 6 edges, on and on and on. So simply we are saying that anything that has a corner, which you call a vertex or vertices, and anything that has an edge is a graph. So we are going to employ the use of graph to solve this problem. Now, so we are going to denote the vertices as the towns and the edges as the representing roads. Now, when we are able to connect all these 6 towns and be able to determine what we call the minimum total weight or the minimum distance, that procedure in doing that is what we are referring to as algorithm. So even though I haven't defined algorithm, you should have a picture of what algorithm is. So what is an algorithm? Well, first, what is a graph? Now, we are going to deal with graph theory, maybe in my 7th lecture or so. And it's a branch of math that also has a lot of diverse implications or applications. So we will deal more with that. But this is an example of graph, hexagon, pentagon, nonagon. Any image that has corners and vertices is a graph. Okay. Now, so what is an algorithm? So I'm now formally defining what algorithm is. Kenneth Rosen defined it as it's a finite, pay attention to the keyword, finite. Finite means it ends. The instructions we are going to deal with ends. Sequence of precise instructions for performing a computation. So if you give instructions that is not finite, then please, you are giving us a literature. Normally, if I'm in class, I normally ask students to give us direction to their home. And that is where you start hearing things like the watches seller at the corner, the neem tree on the road, and you turn left, there's a blue kiosk. I bet you give that definition to, sorry, my phone is ringing. You give that definition to somebody who is not familiar with your area, may have issues. So please, I will recommend that you pay attention to the keywords. The instruction should be precise, it should be sequential, and it should be finite, okay? Now, so when you're able to give these instructions, then we can be able to handle an algorithm. So we are going to pick a type of instructions that we can handle at this stage. I know some of you have got programming background, but for now, I'm going to pick a code called pseudocode. Very simple. What it means is that it's something that is an intermediate between English and then description of English. So we will see more English in the steps I'm going to define. There are more complex codes like Java, C++, and I'll leave that to the programming language, okay? Now, so before we look at how this is done, this is a Prim's algorithm to solve my problem. Now, Prim's is suggesting that I use a graph, and these are the steps to be able to do that. So I'm going to go back to my Excel, show you how to use a graph to do it, then we'll come back here and be able to explain this Prim's algorithm again. Okay, I hope we are back. Okay, now, so I recommend, like I said, I recommend go through all these other towns and see which one will give you the minimum. Now, so this is the use of a graph. Now, remember, I am suggesting that we use a graph to do this. And remember, there are 6 towns. So I basically want to use a 6-sided figure to do this. Now, so what I've done here, okay, I've explained here that vertices represent the towns. So I have a 6-sided figure. Accra is the first vertex, Edina is the second, and on and on and on and on and on, okay? Okay, so based on the information we got at the top, okay? Accra, Yendi, Edina, Cape Coast, Koforidua, this is what we did. So I'm going to copy this. I'm going to pick it to draw my first graph. Okay, it's already here. Now, so what is the plan? Remember, because a graph is a connection from one point to the other, I'm going to pick lines. I already have the lines here, pick them and join. Now, from the table, we said from Accra, the shortest distance was the Yendi, so which is 81. So I'm going to pick my first line, which is Accra to Yendi. So Accra, I'm going to join it to Yendi here, okay? And I'm going to call this my first step, step 1. Now, from Yendi, I went to Edina. Now, this is Yendi to Edina, so I'm going to pick my next line, which is From Yendi, I'm going to go to Edina like this. Okay. Now from Edina, the next time I will go to Cape Coast. And where is Cape Coast? Cape Coast is down there. So I'm going to pick the vertical line. It's in the vertical. Edina, I go to Cape Coast like this. Okay. And now from Cape Coast, so this is going to be my third. Cape Coast, I go to Koforidua. Now Koforidua is here. So I'm going to pick this line. That's going to be my fourth point. Okay. And then from Koforidua, based on the data, I'm going to go to Takoradi. Now Takoradi is to the left. So I'm going to pick this line. I'm going to join it there like this. So that will be my first step. Now, so now you can see that I have a zigzag of lines. Okay. Now, so what graph theory is proposing is that if I draw a 6-pointed graph and then try this will work for Accra. Okay. Accra gave me this type of graph. So if I retry this, okay, for example, let's pick Edina. Edina gave me these values. So Edina gave me these values. Okay. Now Edina, I went to Cape Coast. Now where is Edina? Edina is here. Okay, let me remove these steps. Now Edina, I go to Cape Coast. Now where is Cape Coast? Down there. So I'm going to borrow this line. Edina here. And I'm going to go to Cape Coast. Like this. So this will go to be my step one. Okay. Now I'll go back to the data. Then from Cape Coast, I go to Yendi. Cape Coast, I go to Yendi somewhere there. So I'm going to pick this line, Cape Coast. I'm going to go to Yendi like this. And that's going to be my step two. Okay. Now Yendi, I go to Accra. So Yendi, I go to Accra like this. That's going to give me my step three. From Accra, I go to Takoradi. Takoradi is down at the Takoradi is down on the left. So that will be my point 4. For Takoradi, I go to Koforidua. Koforidua is down there. Now, if you compare this particular graph to the first one, you see that I have another crisscrossing, which is not the same as the first one. Okay, and this gave us a value of 357. So all that this procedure is teaching us is that if I use graph theory, I'm going to get 6 different zigzags of lines connecting these towns. But as I'm doing this, I'm adding up the values. The one that will give me an exact value, or that will give me what I'm looking for, is what I'm going to use. Okay, now, so let me just pick, look at what the algorithm for this particular problem is like if we want to use graph theory. So I'm going back to my slide. And then we will, now this is the definition, or this is Prim's algorithm. Remember, what did we define algorithm to be? It is a sequence of precise instructions sequence. So we must first make sure the steps you are going to give is sequential. Secondly, precise means that every statement I'm going to make, it must end. And then it must be an instruction that will help you to do something. Now remember, I'm using a graph theory. Okay, so I'm using graph. So I said, if I have a 6-sided figure, my first step 1 is select any vertex. And remember, the first one, I started from Accra. The second one, I started from Edina. Now you can start from any other town. So you can say, start from vertex A, vertex B, vertex C. So if there are infinite number of vertices, just pick any of them. Remember, it's going to be a program that will run. So this program will run and will give you the minimum. So we select the first vectors, connect it to the nearest neighbor. Why nearest? Because we are looking for the shortest distance. That is the first instruction. The second instruction is find an unconnected vector. So we connected Accra, we went to Yendi. Now, out of the 6, we've taken 2 towns and connected them. So find an unconnected vector. So it means the 4 towns that are left, which are not be connected. Find the one which is closer to Yendi at that time. And we found out that town and then connect it. So you now connect that town to Yendi. Now, all that you need to do is to repeat this step 2. So you've connected all that. This is the algorithm to solve this problem. And basically, it's as simple as that. Now, I'm going to end this particular slide on this one. And this video on this. I want my videos to be brief. And then the third part, we are now going to take an example of what algorithm looks like and then how to solve it. Okay.